Bell rings.
I'm using my lunch right now.
Excellent.
I don't have time next hour.
Oh, tell me about it. Are we good? Okay. Just waiting to make sure he's ready. Okay, if you could wrap up your conversations, please.
Is it good if Nick and Chris are in the shot? She wants to keep them out of that. No, you just follow her around, ignore her.
And bring your conversations to a close, please. Okay, so before we get started, I just wanted to introduce Mr. Oh no, Yankson, sorry. It's the first time we've met. This is the researcher that I'm going to be working with that's going to be looking at the tape with me. So please welcome Mr. Yankson. Say hi, Mr. Yankson.
Hi, Mr. Yankson.
Hey!
So he is working toward a PhD in mathematics education at the University of Michigan. So, and he is thankful that you are allowing him in the room. He says, is it going to be okay? Is it going to be weird? I said, well, there's huge cameras and a big soundboard and a bunch of other people in here, so I think it'll be all right. It's not any different. Okay, so let's take a quick look at our agenda. I think you know what we're doing today, but just to make sure. So we're continuing our investigation that we started yesterday with creating these similar right triangles. Each of you have a different triangle to start with. Before we get started on that, though, I want to tell you a little bit more about why do we care about this? Like what practical use is this going to help us with? Because right now this is a very abstract investigation, but we're going to be able to use it in very real ways. So we'll talk about that. If we get to it, we'll start talking as a class based on what happened last hour. Probably not. We'll probably talk as a class tomorrow. But of course, you're trying to get as far as you can through the investigation while not leaving anyone in your group behind, right? Because there's some points in the investigation where it asks you, well, what seems to be happening here? And you will all want to have a common understanding of what's happening, so you'll want to make sure you talk to each other. Okay, so obviously you won't have, for example, the same parallel lines, but you should make sure with each other that all of your lines are parallel and make sure you verified that. Because in that example, if your lines are not parallel, all of your measurements will be off, and you don't want that, because then, like I had somebody last hour figure out at the end of the hour that their lines weren't parallel, and he's like, oh no, I got to start over again. So anyway, you don't want to do that. Questions about our agenda? Okay, let me give you a couple of examples. Now, I know you know that my artistic skills are awful, so you can laugh for a second and then move on. This is a tree and a person. So have you ever, we can imagine it's summer for a moment, and you're just lying on the grass, and you're looking up in the sky, and you notice a really tall tree, and you think, I wonder how tall that is. That's really tall. Does that ever happen? No? Okay. All right, imagine that it would happen to you. You can imagine summertime, right? And if it's a really tall tree, it's going to be kind of hard to climb to the top of it and drop a measuring tape down, right? That sounds a little risky, so maybe we don't want to do that. There's ways to figure out the height of that tree, and people do this all the time in the workplace and even in their own lives, like trying to figure out stuff at their house as well. You can find the height of something by just knowing this is a right triangle. You caught that, right? So we have the right angle here, straight up, straight to the side. There's the hypotenuse. If you know the distance between you and the tree and the angle when you look, if you're on the ground looking up at the tree, you can find how tall that tree is. So that's one of the practical ways that we're going to use what we're learning here. So we'll actually solve this problem once we know what we're doing. There's one other situation that I just thought of last night. Mr. Yankson, if you wouldn't mind raising the blinds. If you can see, and you probably already know this, that across the street there's a cell phone tower. And it's really tall. But again, I don't think we could climb to the top of it and drop a measuring tape down. So if I can coordinate it, should we take a field trip and go try and figure out how tall it is someday? Yes. Okay. I just thought about it, and I'm pretty sure that's Independence Township over there, but I don't know that we can actually go over there, and I don't know if they'll allow us to get close enough to the cell phone tower to measure, but I'll look into it. So, because I would like to too, I'd like to know how tall it is. I've been in this room for 3 years and, geez, that's tall. So anyway, so if we can, we'll take a field trip. Sound good? Okay. And we'll be able to all try and figure out how tall it is without having to climb to the top. What's that? Oh, well, yes, not on a day like today, no. Well, since our field trip does not require outside transportation, we can schedule it for whenever is good for us. Yeah, so like a nice sunny day. All right, you can put the blinds back down. Okay, so just thinking about your investigation for a minute, I mentioned the whole parallel lines thing. If your lines are not parallel and you're not confident that they're parallel and you haven't double checked them, please don't start measuring. If you've already started measuring, go back and with your group, like have everyone say, okay, how did we figure out, how do we know for sure that they're parallel? And I'll come and visit you as well, and we can talk through it just to make sure. Because again, I don't want you to have to redo work that you've already done. So just a quick show of hands. How many of you think that you are ready to start measuring, or you've already started measuring? And how many of you are not to that point yet? You're still on page 1? Okay. All right, any other questions before I have you get, oh no, sorry, I need to tell you, just to remind you, your marker is so once you know for sure that you have good ratios, remember those last 3 columns in number 5 in that chart, you're supposed to go write them on your poster. So make sure you write them on the right poster, so group 3 is in the front, group 4 on the window, group 1 in the back, group 2 over by the clock. You're just writing the decimal version of your ratio, right? So you're going to end up writing 9 numbers total, 3 from each column. Okay, so if you have any questions on what to write and when to write it, make sure you ask me. But as soon as you know that in that table you have all the right numbers, maybe you've talked with somebody about, does this make sense how I did this, then you can go write them on the poster and then you can keep going. Okay, any questions about what you need to do? All right, go ahead and get started. What's that? You mean what numbers are you writing?
Yeah.
You're going to write the 3 ratios. Notice that the columns up there are horizontal over hypotenuse, vertical over hypotenuse, and vertical over horizontal.
Oh, and do we have to do all 3 for each?
So you're going to write just the decimal equivalent. So you're writing those 9 numbers.
Do you have to label which ones they are too?
Nope, you can just write them. Yep. Can I look with you guys at your parallel lines first? Okay, you're going to go to the office? Okay. All right, so how do you know for sure that your lines are parallel?
Because they have the same slope.
And did you check that they have the same slope? Probably should, right? Yep, I was coming to your group because you told me you weren't there yet. So what's the slope of your original line? Did we agree that we have to have same slope? Is that what we talked about? Or you're not there?
Like us or us?
Well, your group.
Oh.
John wasn't here yesterday, so not with John.
Yeah, they all have the same slope.
They all have the same slope?
Yeah.
So, and is that what we're looking for to make the lines parallel?
Yeah.
So are you noticing that like the distance right here doesn't seem like the distance there?
Sounds like that one thing you have like
Oh, that's just because I messed up my
But if they're parallel, the distance here should be the same as the distance there.
Yours just aren't close to parallel. Yeah, do this. Oh, okay.
So you guys might want to talk about that a little bit more. I'm just going to be back here, but talk about how do you create lines that are parallel, and how do you make sure that they are? Because it looks like Jared had some lines too.
Yeah.
So Jared, you want to talk, with everyone about how do you know for sure that those are parallel? So I'll come back. Okay.
So.
We have our original line, right?
Yeah.
So now we have to figure out how to draw. parallel lines?
Yeah, I just still don't understand what you mean by drawing a parallel line for DC.
Okay, so some ideas that I've seen some other students use that might help. I've seen students translate their original line segment, so like up one or over one. And then you can extend it farther. I've seen people dilate their points, like C and B, like figure out how far away it is now and then what's the scale factor they want to use. I've seen students eyeball it. When they eyeball it, sometimes it works, sometimes it doesn't, you know. But like we know a lot about how to create similar figures, and we know that we need parallel lines, right? So translations make parallel lines, right? Because we're just scooting it, or however we're doing it. And I would recommend either straight up or straight to the side, either way.
Wait, but, so I know my rise and run it's -1/1. But would that mean my parallel line goes inside the triangle?
Well, you could think of it as a dilation, and parallel lines could be in either direction, right? So where would you put one? Like if you were going to use your pencil to show me what line is parallel, where would you put it?
Yep.
Okay, so it could go inside, and then where else could it go? Exactly. And it doesn't matter where you put it compared, as long as it's a parallel line.
Okay.
So when you think about, so what do you guys think? You want to dilate? You want to translate? What do you want to try?
Probably translate.
You want to try translating? Okay. Do you want to translate left, right, or up, down?
Up, down.
Up, down. So I want you to think about, here's a line segment. You could even use patty paper. And if this point goes up one, so does that one. Should be parallel, right?
Yeah.
And just extend it so it hits the x-axis. Because it's going to be a little longer if you're translating it up, right?
Yeah, how many times can we translate?
Well, you're creating at least 2 more line segments.
So when I want to dive that way, or translate that way, up.
It's your choice. A translation, if done correctly, should produce parallel lines, right? Because you're not rotating it at all.
Is my parallel line? Well, one. Three lines?
Yes, ma'am.
For this, with the answer, how would I like say you can do it like a triangulation or dilation or whatever?
Well, you want to talk about that with each other, like what are ways that you can draw them and make sure that they are drawn
I
correctly.
just don't understand what the question's asking.
How do you make sure you have parallel lines? So how can you draw parallel lines? So you can describe your process, but I would talk with everyone as they get to number 2 as well. What did they say? Like you might have multiple answers, multiple ways.
How would I explain two?
Well, what'd you just do? The only thing you need to think about is we're not translating the whole triangle, we're just translating that line segment, and then you're extending it up.
What do you mean extend?
You're still keeping the x and y axis as the 2 legs of your triangle, and then this is a new, right, because you're dilating really, but you used a translation to get where the line segment would go. See how Letty's is here? Oh, she has
The
3.
way I did it was I just multiplied the x number by the slope, and that gave me the numbers, because I found out that when I multiplied 8 by the slope, it gave me 5. So I thought if I multiplied other numbers by the x-axis numbers, it would give me my y-axis numbers.
So you used your slope as to calculate like what the other point is, or as a dilation, like as a scale factor?
Yeah, I think it's just going to make it bigger by that scale factor. So once I multiplied it by the x numbers, it would have gave me automatically the y.
So what did you start with? Like, did you start with the x-axis number or the y-axis number?
The x number, because when I just tested to see
And-
what it would do, and I multiplied 8 times 0.625, and it gave me 5 where the y-axis number was. So I thought that would just give me the parallel lines for that.
Why are hers longer?
Huh?
Well, so point A is a point in every triangle, right? So you're going to take, and even though you needed to know where that point was to do the translation, you're going to extend that line segment until it hits the y-axis up here. You can extend your graph up if you want to. Does that make sense? Because you're still doing a right triangle here.
Oh, I see it now.
Good. So maybe the other translation that you do, don't go out any farther. Maybe go back in.
I did right though.
So how could you verify that your other two lines are parallel? What could you do to make sure?
Okay.
What's this number here?
The scale factor.
Well, it's really your slope, isn't it?
Yeah, my slope. Yeah.
Right. But you used it, I think you still used it as your slope. You were thinking scale factor. I think you, I don't know. Well, I get what you did. I'm not sure I know how to explain what you did.
Oh.
Does that make sense?
Yeah, I do that a lot
And that's
too.
okay.
I do stuff and I don't know how to explain it.
Right. But if I think about it a little bit more later. So this line should have what slope?
The same slope as this one.
So you want to make sure it does.
Okay.
Does that make sense?
Yeah.
Okay. Yes, ma'am.
Thank you.
I'm getting really confused with the parallel line.
How to make them parallel?
Yes.
Okay. So just as some thoughts, what would let you know that they're parallel? What'd you say here?
Well, at first I had like by dilating the original triangle.
Okay.
And then I said they should have the same slope, but I'm not positive.
Right, because dilation should produce parallel sides. Okay. I've also seen people do translations of their original segment and then just make it longer or shorter. You know what I mean?
Okay.
So what'd you try to do when you did a dilation?
I went up by like the same amount.
So you said instead of making this distance 3, I'm going to make it 6. So how much bigger or how much farther away is this point away from your origin or your point of dilation? Twice as far. So then this one would need to be how far away from the point of dilation?
It'd be twice as far.
Right, so you'd have to extend your
Yeah.
graph out, right? Which I'm okay with you doing as long as you can be accurate. But then you might want to do a dilation that's not that much, yeah.
So like if I did one that's because
Half.
and so then 5 and 1.5.
Does that make sense?
Yeah. So then
Okay.
I should make my graph bigger because I only went up by once. So I should go up by like.
Well, you're doing a half here. What could be another scale factor that you could use that would still stay on the graph? What did we use yesterday as a scale factor?
1.5.
1.5. Where would you put the new point?
It would be about go by 5, but then
And then where would this point go to?
3 be over 8.
Is your scale factor is this compared to your new one?
3, so then that'd be about 6.
And that's double. This was just 1.5, right? If it were double, then it'd have to go up
so
to
then
20.
1 would be 4.5.
Does that make sense?
Yeah.
So yeah, so if you use dilations, which you're using, you should be producing parallel lines. Then you can find the slope and make sure. Does that make sense? Yeah. Okay. We'll go to the hands up first then. Yes, ma'am.
We're still really confused on how to do this one.
We were yesterday.
So what have we tried so far?
Rise over run to find the slope.
To find the slope of the original one. So now how have we tried to create new lines? Don't know yet? Okay.
I like kind of just like skipped ahead, but I just took the rise over run and just noticed that it was just
Well, you have a nice slope to do that with, right? Yours is slope of a -1. Your slope is 5/8. Yours is 10/3, and these are actually negative, right? We're going downhill.
Yeah.
So some ideas that I've seen some other students use is they've used their experience with transformations and either tried to translate or dilate, because we know that translations and dilations produce parallel lines. So which one would you rather try, just to try something? Okay, so how could we And you can focus on, by the way, points C and B, because we know we've done that before, right? Where we used to mark off the distance to find the point, and then we would just connect the points together. So how could we do that here? I'm sorry. The good news is we don't need to mark off distances. We're going to use the graph to help us. Yeah. So, Emma, let's start with yours. So if you have your point C here, what kind of a scale factor do you want to use?
I don't know.
Would it be like 5 for her?
Well, scale factor of 5 would mean we're marking off 5 times the distance. You want to go that far out? Might be
No,
up.
probably just 1.
So a scale factor of 1 would put your new point where?
Up at 6, right?
Is that a scale factor of 1? If you think about that sheet that we used yesterday, so do any of you have it out? So when we figured out the scale factor, what were we comparing? I'll come over, Dane. You don't have to keep your hand up.
You're comparing the original to the image.
To find the scale factor, right?
Yeah.
But notice that we did the length of the segment, which is the number of units, right? It happens to be in centimeters too. So this was a scale factor of what?
1.5.
And notice where this went to. So, and we came up with that by doing 3 over 2. So if you go up by 1, is that going to be a scale factor of 1.5? Are your two distances going to be in that kind of a fraction? Look over here. So you'd be comparing this distance to that distance. Does that make sense?
Kinda.
So what are those two distances if we just look at the units here? How far away?
5,
And
6.
right, so we'd have 6 over 5, or 5 over 6, depending on which way we wanted to look at it. I don't know about you, but that does not sound like a fun scale factor to me, like an easy one. So maybe try one you already understand. So if you use a scale factor of 1.5, where would your new point be? If this is 1, where's 1.5?
Wait, so this is 1?
Right. Remember what we know about dilations. This is a scale factor of 1.
So then wouldn't this be like 2?
Uh-huh, yep. So if you used a scale factor of 2,
So then that would be up here.
yep, that'd be a scale factor of 2. So put a point there. Let's use scale factor of 2.
Mine would go off the.
So you might need to use a different scale factor, right? So now this point, what would happen to that point if we're going to do a scale factor of 2?
I don't know.
It would be like. You would just go 8 over again.
So you're going to go twice the distance, right?
Oh, okay. So it'd be
so
like
mine-
over here, right?
Mm-hmm. So you can extend the graph out if you think you can be accurate.
So my scale factor just
Draw a line.
Where's your original one? Right here?
Yeah.
I'm gonna be so confused.
Well, you don't necessarily have to find a scale factor if you think you have parallel lines. Have you verified that each of these has a slope of -1?
Yeah.
Have you like calculated?
I don't know how to do that.
Well, how did you verify? What did you do?
Well, I just did it like with my eyes.
Okay, so you saw that every time you're going up 1 over 1 and actually down 1 over 1, right? Okay. So you could do it with a slope triangle. These two don't have nice, like, it hit at an intersection, right? So they're using points that, so you'd be able to have a new triangle here.
Okay.
So your next triangle, you don't want to go any bigger than 2, right? Because it's almost going off your
Yeah.
graph as it is. So Julia, what kind of a scale factor are you using? That would be 1.5 that you're using. Does that make sense? If this is a scale factor of 1, that'd be 2. So right, you're going a half more, which would be 1.5. You get the concept, just to make sure you have the language right. Do you guys feel like you can go from here?
I think so, yeah.
Okay, awesome. All right, I'll come back over in just a minute.
I was wondering, are my parallel lines D and F have
I
to
don't
be
feel
on
like
the
they
line, not B and F.
Just looking, this looks a lot closer together than that looks farther away. So probably not.
D, B goes up here.
So do you want to erase the two additional ones that you have? Because Daniel, of course, got the easy version
I put B as my, okay, so this is my first triangle, A, B,
because his slope is a
okay, A,
lot easier to figure out.
like, so A, B, C, and then A, F, G, so that's G.
So when you tried to draw this first line here, what did you do to try and,
I just thought the distance between 3 and 10 is 7, so I just by 7.
I'm sorry, say that again?
The distance between 3 and 10 is 7, so 12 and 5.
Now you're comparing vertical distances with horizontal differences. Can you just subtract?
Like, what do you mean?
So you're taking a 10 on the y-axis, which is 0, 10, and comparing it to an x-axis number, 3, 0. Can you just subtract when you do that?
Yeah. Can I subtract like 10?
So are you telling me you think this distance is 7?
Yeah.
So this distance is 10.
Yeah.
Does this look like it's going to be 7?
No.
So does that make sense to do that?
I don't really know how to draw it. Like,
Well, I get what you're saying. So what'd you do from here to here?
I just went up by 2 and 2.
Okay, so is this side, so think about scale factor. If you went up 2 here, you're comparing original to image. Is that going to be the same kind of dilation?
No.
Right. So I want you to think about what we did in that original piece of paper here. When we came up with the scale factor, we were comparing this side to this side, and actually it was this one over that one, right? Okay, so if you picked a scale factor, could you come up with where points C and B need to dilate to?
Yeah, so when I just really guess and check that.
Well, no, we know how to do dilations, right? So what might be a good scale factor that you could use that'd be easy?
Or 2.
2, okay. So if you were going to dilate this point, here's your point of dilation, right? Or center of dilation. If you're going to dilate that point by a scale factor of 2, where's it going to end up?
Isn't that going to 20?
Uh-huh, which is maybe a little too far, right? Okay.
So 0.5. Can I do
0.5, okay, so if this is a scale factor of 1, where's a scale factor of 0.5 going to move C to? That's 1.5, right? Because this is 1.5.
5.
Okay, so put a point there. So you've just dilated by a scale factor of 1/2. Okay, so now you have point B. There you go. So now we know a dilation produces parallel sides, right? Parallel segments. So you just took and went down by into a half, into a half. So should you have a parallel side?
Yeah.
Right. And then you can double check by seeing if their slopes are the same. And then you can do another scale factor to find. Sound good?
Yeah.
Okay. All right. Excellent. Okay.
Because it says millimeters, but it's
So these big numbers are centimeters, and the little tick marks are millimeters. So you want to measure to, so like that's 20.5 centimeters right there.
that kind of
Yeah, I don't understand why rulers do that. Doesn't make sense to me. And I don't know if it's because I have old rulers or. Anyway, yes, ma'am.
You knocked that down, and that was mine.
Whatever. Sorry, Lily. So when I'm doing this, I'm not exactly understanding. I don't like get it because am I supposed to like just measure what
Let's
they
take
are
a
in
quick look.
centimeters?
Did you get parallel lines yet? Maybe? So we should look at it? Okay. All right. Do you feel like you have parallel lines?
Yeah.
Okay. All right. So what were you asking again?
Like, do I just measure this here?
Yes, it says complete measure each segment to the nearest 1/10 of a centimeter.
Okay.
So 1/10 of a centimeter is all these small little ones
Okay,
here.
Yeah, so I was
Yep.
doing that right then.
Right.
Okay.
So you're going to measure leg AB or side AB and put the measurement,
Okay.
5.3 centimeters.
Oh, okay. That's why
Right.
I was the number one. Didn't
And I want you to, so when you go to this triangle, what's the side that you're measuring? So
Okay.
list it like I did here. Okay. So you said this is your original one, or this is?
This one.
That's your original?
Yeah.
So what did you do when you drew this line?
Well, Letty helped me out.
Okay.
I
What-
don't know what I did.
What'd she tell you to do?
Oh, okay. What I heard was like the rise over run. Right?
Uh-huh. So you have a slope of -3/10, so put a negative in front there. All right. So now what?
I don't know.
I explained it twice.
It's okay. If I still didn't quite understand exactly what you were saying, and I do this all day long,
Yeah.
doesn't mean it's bad, Letty. It just means we don't quite get it yet, right?
You're too advanced for us.
That's all right. So I'm wondering if we should do a new one. Let's do, you have, this is a distance of 10, right? Remember yesterday we had a scale factor of 1.5? So if this is a scale factor of 1, where would 1.5 be? How, like, where are we going to move that point to get to 1.5? Let's try this. Let's do a half. So if this is 1, how did we do half that? Where's a point that's going to be half that distance? Yep, put it on there. Let's make that point D.
Wait,
Let's make that point D. Okay, this one's I think supposed to be B. And that one's supposed to be C.
isn't the hypotenuse supposed to be these two numbers?
What's that?
Isn't it supposed, the hypotenuse supposed to be like these two or something? Like
The what?
together? The hypotenuse.
It's supposed to be what?
Isn't it supposed to be like something to do with these two numbers?
Yeah, leg
and, like-
squared plus leg squared equals hypotenuse squared. But you don't have to calculate it, measure it.
Okay.
Does that make sense?
Yeah.
Okay. All right, so now if we look at this distance here and we do a scale factor of half, where's half of that distance? Where's that point going to be? Yep, put it down. And then that point is going to be E, so label that E. So now when you draw that line segment, we've dilated to half. So we should have a parallel line, right? So maybe you use that process to make sure this one is, what I think Letty did is, it's a scale factor of
We don't even know what you really did.
7/5.
Something and it looked seemed like it worked.
I feel like one of
think
those
it's a
people that discovers something new, but
It,
don't know it's
yes, that's definitely what's happening. It's not something new, but you think about it. When I see your work, you understand things in a different way from most of the students, but you still understand it.
I'm ADHD.
Well, and it's not normally the most straightforward way. You kind of do this sometimes. Right, you go through more steps, but that's fine. I'm good with it. I'm not saying you should change. Just saying it doesn't easily translate sometimes.
Find the horizontal.
A lot of times it's like speaking another language. to
So
me.
this is the horizontal leg length. That's the vertical leg length. That's the hypotenuse leg length. So you're just going to take the numbers for A, B, and B, C and put them here and here, and then divide and find the decimal.
Okay.
The hypotenuse is always the longest length, right? Or is it?
It's
Is
always
it?
the one not connected to the right angle, right? Okay.
Does that make sense? You're going half the distance from here to here, so down to here. Do you remember doing dilations last semester, and we would shrink and extend things out? And so you're just dilating the 2 points. And then drawing the line between them. Remember when we would mark off the distance last semester on the line of dilation to figure out, like if it was a scale factor of 3, we go 1, 2, 3, and then mark that point, and then go 1, 2, 3 over here, and then connect them. Same thing here. What's that?
You just put the rise over the run.
Decimal. Shouldn't it be a fraction or no? Or just decimal?
We want the decimal is the last number. The decimal is the last number. Okay, I haven't been to all these tables yet.
So horizontal hypotenuse, this would be the.
Yep, so you're going to write down 0.708, 0.710, just like they did. Except for there's like 8 people's numbers that need to make it in there. That's okay. How are we doing here? Good. Can I look at your parallel lines with you? I'll come over here. Because I don't think I've seen them yet. Have I? Have I seen all of your parallel lines yet? Oh, he's writing his down. So how do we know for sure that we have parallel lines?
Well, mine just goes right through that.
You have a
One,
slope of
yeah.
-1. Yours was easy, wasn't it?
Yeah.
Am I doing this? Or just the first one?
You're doing nine numbers total.
Okay.
So you should do all 3 numbers in that column, then your 3 in the next column. So how do you know for sure that you have parallel lines?
Well, I know for this one I divided this by 2,
Divided what by 2?
both these numbers. So the 10 would go to 5 and then the 3 would go to 1.
Ah, so you dilated by half.
Yeah.
I don't know, did you realize that's what you were doing?
Yeah.
Okay, so you took this and you divided 3 and came up with 1/2, divided 10 and came up with 5.
Yeah.
Okay, all right, and then what'd you do to get the other one?
Well, I saw that this was 1.5, and so I added 1.5 to this one, and then added 5 to
Okay.
10.
So a scale factor of 1.5. Okay, can I just look at your parallel lines for a second?
Yeah.
Ah, so you translated.
Not really. I just like picked a random one and made sure the slope was the same. I mean, I guess, yeah.
You kind of did though, because look, because you went up 1, 2, 3. You started here, you said? You started with this point?
Yeah.
And then you made sure your slope was the same, so you went to here. So notice that line segment is just this one translated up
Yeah.
3. You
Yeah,
didn't even
so then
know
I
it.
did translate.
Yes, you did. You didn't realize it though.
No.
I've actually seen some people like mean to translate, and then they just extended their line segment, but excellent. Just have to make sure you all have parallel lines. All right, cool. So does that mean you're all like on number 6 then? Are you all done measuring and?
I'm on number 7.
Yeah, I'm on number 7.
Okay, can you guys go back to number 6, unless you've already done this, and look at each other's like tables, and you're looking for commonalities, like what kind of patterns do we see that are true in all of the tables? Does that make sense? So you're trying to come up with what do you see? Good? Okay, all right. Who haven't I seen lately? Do we all think we have parallel lines now?
Yeah, pretty sure we do, because we all wrote them up on the board and I looked at everything.
So can I see yours for a second? Okay. I think we're good. All right. So you guys are waiting. What are we waiting for? Why are we on our phones? To be direct.
We're waiting for to finish. Yeah, I just finished.
Okay, so now we can talk about number 6 together? Okay, so I'm wanting you to see if you can find what is similar, what kind of relationships are true in all 4 of the tables. Does that make sense?
Yeah.
So we won't necessarily have the same sets of numbers because we all had different triangles, but we might see some patterns that are true in every.
Okay.
Make sense?
Yeah.
Okay.
No, nobody does. I'm just saying you could like, I mean, you know how most dogs like free.
How are we doing here?
Not good.
Not good.
We need to figure out how to do this.
I was
Okay.
wondering, is this how you do like the? Because I took the length of like because I have
Let's look at these first. Can we make sure our lines are parallel first?
they are parallel because they have the same slope.
You know for sure?
I'm just guessing.
Well, you had a slope that was easy, right?
Yeah. All you
okay.
have to do is get it 6.
Ah, okay. So this is fine, other than you got to extend this all the way down because we're looking at another triangle here.
Okay.
Or did I just totally wrong?
It's not totally wrong, but same thing with you. So you guys translated, right? So you know you have the same slope because you just translated. But what I need you to do though is to make this extend to here, and then instead of including these 2 lines, maybe we do one that's this way. Right, so the line doesn't have to be as long, but if you translate even over 1 unit, where does it, because you're looking for triangles where A is still in the same spot.
So do one over here, like in here.
Yeah, so you would need to, Carson, I think it's going to be easier for you, and just because I want you to be able to finish, move it down 1 or 2, and then extend it over to here, so you don't have to extend the graph out, the graph paper, and then I would do one that's translating down, and then when it cuts off, that's as big as the triangle is.
From here.
I think that one will be okay because you're just going up 1 unit here,
Alright.
right? But then I would maybe translate in or to the left. You need 3 total.
Okay.
Because you notice how Josh has 3 triangles that are all kind of nested inside of each other. They're dilations of each other. You want the same thing.
But for the
Okay, so now measurements.
since this is like the original, it would be going down like a negative scale factor, basically. Or could you have?
So your original is here. Yes, you have a negative scale factor, but you don't have to calculate your scale factor.
I thought you did.
Oh.
For
So what you're measuring here is you're measuring in centimeters. So you're using this, right?
okay.
So you're going to measure in centimeters to the nearest tenth. So that's the little ones there. So then when you get to this, if these were your actual numbers, you would put 10 over 14.4 right here, and then you would figure out the decimal equivalent, just like we did here. We did 3 over 2 and equals 1.5, so you'd have 3 over 2 equals 1.5. But I want you to write these labels down so you know what you're trying to measure and trying to calculate.
I should probably actually measure the thing.
Yes, and try and do that before we leave. Could I have everyone wrap up your conversations for just a minute, please? Oh, thank you. So we are close to the end of the hour, and what I would like to make sure is that by the time we get to class tomorrow, that all of you have measured and then calculated all your ratios. Okay, so some of you are that far, no problem, and I want you to make sure that you've talked about all of your 4 tables, like the number 6 question, before you leave. But if you have not gotten that far, make sure that you have measurements and ratios by tomorrow. So that might mean a couple of you have homework, so I apologize for that. Well, whatever. We just need to be in that spot where we all have numbers by tomorrow. So if you need to keep working, we still have about 3 more minutes, and then I'll play announcements at that point. So you guys for sure need to keep working. At least so you have your measurements. You can do your calculations at home. Mr. Banks, we can finish. Yeah.